The real number system. So we're going to do the presentation now. So the real number system, what is this? We're going to talk about evaluating algebraic expressions and given valuables for the variables. We're going to talk about translating phrases to algebraic expressions, so taking something from words and putting in symbols, because if you think about it in your everyday life, you're not presented with an algebraic equation. You're told that, hey, this item is 20% off. You don't have 0.2 times x equals your savings. So it's really important to get these skills down to where you can translate from words to equations so you can solve your own problems in real life. We want to be able to identify solutions, and we want to be able to distinguish between an equation and an expression. That's a very important distinguishing in the lab. A constant is just a number. It's a new word for us. We're going to call all numbers constants in this algebra course. A variable would be a symbol that represents a value. So less than or greater than is not a variable, but x, because x stands for a number or a value, would be a variable. An algebraic expression is a sequence of operations that is not equal to anything. Okay, you have no equal sign. Therefore, algebraic expressions cannot be solved, but they can be simplified. So in the lab, you're going to hear that word simplify versus solve, and that's going to help you identify what you're dealing with. In 2m, it's really important to realize that is 2 times m. So what happens is when we start learning multiplication in the lower levels, we write that 2x3 is 2 times 3. Well, then we hit algebra, and all of a sudden, that's 2 variable x3. So what we've done is we've taken out that x for multiplication, and we write two numbers next to each other, or a number and a variable next to each other, and that implies multiplication. So there's not confusion on x versus the symbol for multiplication. So this is a key word you're going to see in the lab, evaluate. Evaluate means plug in. So if I want to evaluate the expression for p equals 3, it means plug in 3. Now, this does not do what I like seeing. Whenever we plug in, I really want you as a best practice to use parentheses. So I want to see 16, open parentheses, 3, close parentheses. This is very important as we approach negative numbers for this. Go ahead and put parentheses around it. The calculator will calculate this in Web 2.0 with parentheses. So then I would say 2, I would put open parentheses, 3, close parentheses, raised to the third. That's just good calculator etiquette. And just as a reminder, that is 2 times p cubed. The 2 itself is not being cubed. So again, we're going to plug in and we're going to use parentheses because this is important as we get to more complicated ones with our calculator. So I would say 4 open parentheses, 6 close, 5 open parentheses, 9 close parentheses. Same thing in the division. That's just going to help you get the calculator to be trained to do the proper thing, okay? Same thing here. I would open parentheses 6, close parentheses squared. And again, that's not a mathematical rule, but as we get later in the course and we're doing more complicated calculator entry, it's going to be really helpful to do it that way. So let's look at translating words and algebraic phrases. A number subtracted from 48. This is the most common one. So if you guys have taken a foreign language, you've probably learned the placement of adjectives can be different in different languages. So I might say, look at that scarf blue. Well, if I'm talking in Spanish, the blue is going to come behind the word scarf, but in English, that doesn't make any sense. So in math, the subtraction is happening in reverse. So this means 48 minus a number. That is a unique thing to subtraction. The product of 6 and a number, that goes in regular order. Product is multiplication. We don't write a multiplication symbol in algebra. 9 multiplied by the sum of a number and 5. Okay, so see that of preposition? When we see of, if there's an operation implied with the of, it is a grouping symbol. So that of is going to be the trigger. So sum of, that's going to tell me it's parentheses around a number and 5. If it was just a sum of 5, I mean, I could put parentheses around a 5, that's fine, but it's not two things happening. So think of this as a prepositional phrase, and everything in that prepositional phrase is a sum, so it's grouped together. Equations can be solved because they have the equal sign. When I'm working an equation, to solve an equation, we do what we call inverse operations, and that's a really big word. It's just the word for opposite. So if I have plus 4, to get x alone, I need to minus 4, and I got to do it from both sides to keep them equal. So when I'm solving these things, they're always going to be getting the variable alone. And we're going to learn how to solve for things like z squared equals 4 as the course progresses. But an equation has a one value answer solution, or if we start getting later in the course, we're going to have some that have 2, 3, or even 4 solutions. But for now, mostly we're dealing with linear, and there'll be one solution that comes from doing the opposite. So I need to decide, is 2 a solution for this? This seems kind of like a weird question, right? I'm asking you to work things backwards and tell me, hey, is this a solution? To find out if it's a solution, you just plug it in. And again, a best practice would be to replace that p with parentheses and then put the 2 in right here. So this is where the book will start catching up to me and saying to use parentheses. And I get 5 equals 5. So because I get a true statement, it is a solution. If I got 4 equals 5, well, first of all, you're going to be like, that doesn't make any sense. But that means it would not be a solution. So true versus not true is how you look at that. Let's say I have a set. A set is a collection of items, okay? So think about if you're collecting Star Wars figures, that's a set. So when I'm looking at a set, they're typically going to be a grouping of numbers in math, and we call each number an element. So what's inside the brackets would be the elements. So the elements of this set are 1, 2, 3, 4, and 5. One way of determining if a solution is, if an element of a set is a solution would be to plug in. And everything that gives me a true answer is a solution. So this time I've given you something in words. 3 times a number is subtracted from 21, giving 15. So remember, subtraction works in that reverse behavior. So I'm going to actually put that 3 times the number in the back. Giving 15 implies equality, or is 15 would also imply equality. I'm going to plug in from my set. So if I plug in 2, do I get a true statement? If I plug in 2, 4, 6, 8, and 10. The only one that works is 2, so that is the only value in my set that is a solution. There's no shortcut to this, guys. You got to plug in each number. You could solve for x and know that x is 2. That is possible, but most of the time when the lab is asking you to do this, it's going to have multiple parts asking you, is 0 a solution? Is 2 a solution? Is 4 a solution? So it kind of makes you bypass that. And like we've talked about, the difference in an equation and an expression would be the equality symbol. An equation has an equal sign, an expression does not. An equation can be solved, and an expression can be simplified. So here are 2 examples with the same basic thing. 4 times the number plus 5. So if you're looking at these, which one would be the equation and which one would be the expression? Well, B would be an equation because I have equality, and A would just be an expression. And that is the end of 1.2.